everyone. Welcome back to another exciting day in mathematics. Whoop, whoop. How's everybody doing? Good? Yes, Mr. Q. All right, warm-up number 49 is on the screen. Let's get started, please. I'll give you guys about, 5 minutes? 6 minutes? 5? All right. Get cracking. Oh, by the way, you are going to need your Chromebook, so make sure you get those handy, please. Oh, man. So warm-up number 49 in your agenda. We just finished. We're still with transforming functions, and your hopefully for tonight is only one problem. Okay? So let's see, as you're copying that, let me address the warm-up really quick. So for the warm-up for number 1, you should have gotten dividing points was negative 4.5 and negative 2. So you should have written the solution set of x such that negative 4.5 less than or equal to x less than negative 2 in close parentheses or bracket. Number 2, x equals negative 2. When you cross multiply, you ended up with x squared minus 4 equals negative 4x minus 8. Get everything to one side, Power Rangers and such. And for number 3, this equation for this one, it's this line's crossing at negative 5, and the slope is going down 1, 3 steps to the right, so the slope is negative 3 and 1. All right, so no nearby code. Last weekend's home play, that's a gift from me to you. Thank you, Mr. Q. You're welcome. But make sure you're practicing your home play, because today we're moving on. Let's go. We're going to continue adding more parameters to our transformations. Tonight's home play, take a picture of that, please. It's only one problem, and it says graph f of x equals x squared. Today I'm going to do a formal introduction to quadratics, and we're moving on. And now if you notice, instead of just having 2 transformations, we're going to have 4 different transformations. Okay? All right. So, here we go. Our objective for today, I can transform a function using different parameters. I can transform a function using different parameters. I can transform a function using different parameters. Ivan, you all right over there? Yes? Okay, good. Ivan, you all right? Yeah, okay. Oh my goodness. All right. So, do we need a Ferrer model? Tell your neighbor the definition for functions in your own words. They should know by now. All right. So type it in without looking at your notes. We should know what that is by now. 30 seconds. Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1. Time. All right, look at your screen. You should have written relation somewhere. Yes? And of course, 1-to-1. For every input, there's exactly, keyword exactly, 1 output. Okay? And there's the one that you filled out before. All right. We're still on parameters. What are parameters? Numbers that transform one function to a new function. Last week, we covered that we started with 2-variable equations, like the one you have on your screen. And from there, we moved on to function notation, which the only thing that changes the y to f of x. Yes? Then we did an activity. Oh, my goodness, Lai. We did an activity where we did 3 different tables with transformations. Yes? And then we said that the green one moved, it said f of x plus 5. That means it moved the original function 5 steps upward. And f of x minus 2 moved the original function 2 steps down. That's where we got our new general rule, g of x equals f of x plus k, where our k is a parameter. If we substitute a positive value, it goes up. If we substitute a negative value, it goes down. Yes? Yes, Mr. Q. Okay, we're ready to move on, yeah? All right, so with that said, oh, hold on, let me capture this. Oh. All right, so I gave you guys a practice one, which was this one, is that correct? Yes? So, just for the sake of it, tell your neighbor what's going to happen to this function according to the green one and what's going to happen to the same function according to the red one. Tell your neighbor, please, see if they remember what they did without looking at your notes. All right. All right, Valente, what's the green one going to do? Valente from the corner, let's go. All right, so, and once again, our general rule is g of x equals fx plus k. Today we're going to add more to that. How about the m-apples? Copy this, please. Example super cute. And it says graph f of x equals x squared using the domain -2, -1, 0, 1, 2. Those of you that were able to get a graph paper, you should have one blank. Use a medium-sized one, so like that you have space to copy the 3 tables. I need one in black, one in green, and one in red. Bless you. I'll give you some time for that. Copy that, please. All right. So with that said, it says graph f of x equals x squared using the domain -2, -1, 0, 1, and 2. Okay? So I'm going to fill this in. We started last week. I did a formal introduction, informal introduction. Today's going to be a formal one. So students, quadratic functions, students. So look up. From now on, whenever you see f of x equals x squared, notice that it's x squared. There's nothing else around it. This is known as a parent function because that's the original function of a quadratic. Let me repeat that again. This is a parent function because that's the original one. Tell your neighbor the name of this again. Yeah, parent function, okay? So to fill our table, I'm going to start by substituting values into here so that we can evaluate. I'm going to start with what? -2 for each of the x's. So I'm going to write it down here. F of -2 equals parentheses -2 squared. So question, what is -2 squared? 4, so that means that goes right there. Next value is going to be what? -1. So I write f of -1 equals -1 squared. So what is -1 squared? -1 is -1 times -1, which is 1, yes. So basically, you're saying, Mr. Q, we're just taking this number and multiplying it times itself. Yes, because we're squaring it. So -2 times -2, 4. -1 times -1, 1. 0 times 0, 0. 1 times 1, 1. And 2 times 2, 4. All right, let's plot those, please. -2, 4. -1, 1. 0, 0. 1, 1. 2, 4. And once again, these are quadratic functions. Students, quadratic functions, students. The name of this graph is also known as a parabola. I had already introduced this about 3 weeks ago or so when we got to solving quadratic equations 3 different ways. We still have some more to go, but that was the simple introduction. So there it is. Arrows at the end. All right, so that we label f of x. We good, yes? This is our parent function. So from now on, when I ask you to graph f of x equals x squared, you're probably not even going to need to look at the process because you already got this. You would say, okay, -2, 4, -1, 1, 0, 0, 1, 1, 2, 4. That's bread and butter from this point forward. The second thing that I want to remind you, because this you should have covered when we were itty-bitty 7th graders or 6th graders and 8th graders, and they introduced parabolas to you. Your teacher should have covered the name of this point right here. Of the graph, not the coordinate plane, of the graph. That point, which is the lowest point, sometimes it's the highest point, is known as the vertex. Tell your neighbor the name of that point, please. Yeah, the vertex. So keep that in mind because we're going to be talking more about this as we move along, okay? So we're going to take this original function and now we're going to do a transformation. This is a little bit different from what we did last time that we were here. And I want you to notice the difference. Look up to the screen, write your utensils down. Check this out. This one has f of x minus 5 close parentheses. Look how different it is from last week. Last week, look at this one. What do you notice here? We have f of x close parentheses and then plus 5 outside of the parentheses. You see the difference? Yes, Mr. Q. So that means today is going to be a little bit different from what we did last week. So write your utensils down. Let me show you the first value so you can see. Here it goes. I'm not even going to speak. I'm just going to show you the work. Here it goes. This says f of x minus 5. X minus 5. Copy that. You're like, what? Oh yeah, we got this. We got this. All right. So here goes again. This says f of x minus 5, but then we did squared. Why? Because now it's a squared function. All right, so let's see. What do you think I'm going to write next? Don't say it out loud. See if you get it correct. So with that, fill in the last 3 by yourself. See what you get. Last 3. So let's see if you got it. F of x, which is 5, minus 5 is 0, squared, which is 0. Next one, again, x is 6, minus 5 is 1, squared, that is 1, excuse me. And the last one, 7, minus 5 is 2, squared, that is 4. Hands if you got that by yourself. All right. Let's plot those. 3, 4. 3, 4. 4, 1. 4, 1. Now I'm doing this in green. 5, 0. 5, 0. 6, 1. 6, 1. 7, 4. 7, 4. Graph your new parabola and label this one. This is no longer a parent function, so it can't be f of x. What are we going to label this one? Yeah, g of x. G of x. All right. So, here goes the observation, though. If somebody walked in and you didn't show them all this work and they saw the original, what would you say happened to the original to get to this one? Talk it over your neighbor. What happened to the original to get to that one? Tell your neighbor, please. What would we do to the original to get that one? What do you think, Joel? Moved over to which direction? Moved over to the right. Okay. So far, so good. You are right. But be more specific. Moved over to the right 5 steps. That is correct. All right. Tell your neighbor if they see that on the function. on the original function of the table. You guys see it? Yes? Yes? Yes, Mr. Q, I see a 5 right here. Positive 5, so we move it to the right. Okay. So make a prediction. Tell your neighbor where this red one would move the original f of x. Where's that one going to move? I heard to the left. Let's see. Let's fill in the values. Here we go. We got x is negative 6 plus 4. That's what? Negative 2. Square that. That gives us 4. Next one. Negative 5 plus 4 is negative 1 squared. That is 1. Next, negative 4 plus 4 is 0 squared, which is 0. And finish off the rest. Plot your points and see if it moves it to the left, as you guys said. All right, let's see. Negative 6, 4. Negative 5, 1. Negative 4, 0. Negative 3, 1. And negative 2, 4. Did it move 4 to the left? Yeah, left 4. Okay. So, this is what I want to bring to your attention, though. Look up, let's label this one g of x. All right. So look up really quick just to make sure you don't get lost from this point forward, because this is something that gets people confused in their noodle. Here it goes. Look up. Write your utensils down. So Joel said that the green one, we move 5 to the right. And he's right. We move 5 positive steps. Or look at the vertex now. The original vertex was at 0, and this one moved to what? Positive 5. Which means, look up, we're not paying attention to this negative here. All we're looking at is this number right there. What is that number? It's a positive 5. It's a what? Positive 5. That's why we move to 5 in the positive direction. Okay, you're saying, so what about this one, Mr. Q? Well, this one, it's a little bit different because now we have a positive here. So let me write it like to make it look like this. F of x minus blank. So if I was to use the same format, here they substituted a positive 5. We moved it 5 to the right. So this one moves to the left. So what shall we substitute in here if we move to the left? Negative 4. That's where we move to what position? To negative 4. So now, what is negative times a negative? Positive 4. That is correct. So this has to do with the form or the general rule that I'm going to give you today. Okay? But that's something that I just wanted to bring to your attention. Okay? So from 1 to 5, how comfortable are you with it so far? Yeah? 4 5s, 4 5s. Okay. All right. So with that said, send me a picture of your notes really quick. So I got most of your work. All right, thank you. So now check this out. Let's see if we got it. Without talking to your neighbor, I want to see if you got it. Look at this next one. Don't copy it. It says, the graph f of x is shown. That means this black n is f of x. Okay. So the green graph, without making a table, using g of x equals f of x minus 2, you should know where to move that and graph that to. Is that correct? And then if you change colors and you go to red and you are written g of x equals f of x plus 6, you know where to graph that one as well. Is that correct? All right, so on your screen, graph me the green one in green and the red one in red on your screen. I'll give you some time, and go. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, and time. Look at your screen. Correct answer. And another. And another. And another. And another. And another. Another. Blah, blah, blah. All right. And another. We got this, yes? All right, from 1 to 5, I'll come through. Are you with that? Yeah, all right. So on your Cornell notes, write the new rule for today. Our new rule. G of x equals f of x minus h, close parentheses, plus k. And then leave 1 or 2 lines underneath that free, and then copy that table, please. Don't fill it in. Just copy it exactly as it is. Yes? No, on your Cornell notes. I'll give you time to copy that. Copy and go. All right, so before I give you an activity to do and fill that table with, let's finish up our general rule. Let me zoom in. All right, so our general rule now is G of x equals f of parentheses x minus h, close parentheses, plus k. Now, one thing to observe, look up, is that what's still the same from last time that we met? G of x, is that correct? Equal is still the same. The f or function is still the same. Parentheses is still the same. The x is still the same. What's new is that now we have a minus that needs to be there all the time. The only time it changes is when we substitute values in there, and I'll show you in a little bit. Close parentheses, so we have h, our new parameter, and k from last week. Remind your neighbor what k does to the entire function. What does k do to the entire function? Yeah. Jaden, go. K goes what? In what? In a direction, yes. Which direction? K moves our function. Everyone, show your neighbor which direction it moves in. Yeah, up or down. So draw an arrow upward on the side with a little plus sign. If we substitute a positive value in here, it's going to move our function up. Or it's going to go downward if we substitute a what? A negative value for k. All right, that was last week. This week we have h, which means what? It moves it to the right whenever we substitute what? Guys, whenever we substitute a positive value, it moves it to the right, and it moves it to the left when we substitute a negative value. So just to clarify, check this out. I'm going to write a function over here, the function q. And this one is my original f of x. You don't have to copy that, just pay attention. So let's say I wanted to move this function from where it's at 7 steps to the left. Think about it. 7 steps to the left. What value do we substitute, and where do we substitute for that general rule? Talk it over to your neighbor. What do we substitute and where? What and where? What and where? Jaden, pass someone. Jalen, what do we substitute and where? So we're going to the left, so we're going to substitute, we need to go to the left, so we substitute what you said? For H, yes, so far so good. Yeah, so we substitute -7 in order to move it to the left in here, which means now my new rule would be g of x equals f of x, negative times a negative, positive 7. That is correct. All right, let me erase this really quick. I'm just trying to clarify to make sure we got this part. All right, let's do another one really quick. Once again, you're not copying, just paying attention. Here it goes. I want to move this 3 steps up. What do I substitute and where of that function? Talk to your neighbor. What do I substitute and where? Jalen, pass someone. Jose. K, positive 3 for K, so it can go up. That is correct. So my function would be g of x, which is this, equals, there it is, f of x, that and that. Does it have an h? Did we move it side to side? No, so we close this because there's no h. And then we just do what? Plus 3, because it's going to go up. Ooh-wee, let's go. One more. Let's say I want to move that function 10 steps to the right. Tell your neighbor what goes where in order to move it 10 steps to the right. 10 steps to the right. Jose, pass them on. Joel, 10 steps to the right. Where do I substitute that 10 into, or what do I substitute? So positive 10 for the h, so my new function will be g of x equals f of x, but now we have an h, so this is minus 10, and that goes to the right, and that is correct. And notice I didn't write anything at the end, no k, because we didn't move it up or down. All right, here goes a challenge one. Ready? I want to move this 2 steps to the left and 3 steps down. Talk to your neighbor, let them know what goes where. And then, Joel, you're going to pass it to someone? Go ahead. Valente. What goes where? -3 on the K, okay. So it can go down. So far, so good. Let's go. Let's go. That is correct. So that means we would get g of x equals f of negative times a negative is a positive 2, and then at the end minus 3, and that's moving it 2 to the left and 3 down. From 1 to 5, how comfortable are you up to right there? Okay. I think we got this, yes? Well, let's see if it's true. Without helping your neighbor, move that function in green to where it's indicating it, in red to where it's indicating it, in blue to where it's saying it's moving, and in black again to that direction. I'll give you guys some time, and go. All right, do me a favor, for the sake of time, submit what you have so far, so I can show what you did. Hurry up, hurry up, hurry up. So I can show you the correct answer so far. All right. Correct answer so far. Here it goes on your screen. The green one went in which direction, everyone? Up 2 steps. The red one, 3 down. The blue one, 6 to the right. So tell your neighbor where the black one's going to move now. 7 to the left. Okay. So with that said, I'm going to take you back to the to this table that you copied on your paper. Yes. Open up a new browser, and I want you to go to student.desmos.com. It's on your screen. There's a code, and I want you to go to the last slide of that presentation. There's four slides. I want you to go to the last one, and I gave you the function with levers, so you can move stuff around and answer or fill in your table according to what the sign of each one. Bless you. Move all the way to the last slide. There's 4 of them. And I included 2 levers, one for H, one for K. Fill in your table as you move it along. You have 3 minutes. 3 minutes. All right, and I'll stop right there. The video, those of you that are still on Desmos, continue on so you can fill in your table.